Welcome to physics class. Today we will discuss question number 5, 6 and 7. First of all, question number 5. A driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 km per hour in another car applies his brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graphs for the two cars. Which of the two cars traveled farther after the brakes were applied? Let us calculate and plot the graph. For car 1 or first car, initial velocity u is 52 km per hour. We have to convert it into the meter per second. 52 multiply 1000 upon 3600. It will be 520 upon 36 means 14.4 meter per second. Final velocity 0. Time taken 5 seconds. For second car, initial velocity u is 3 km per hour. Again we have to change it into meter per second. 3 multiply 1000 upon 3600. It will become 30 upon 36 in turn, which is 0.83 meter per second. Final velocity is 0. Time taken 10 seconds. Let us plot the graph now. Draw x-axis and y-axis on a graph sheet. Mark the origin as 0 and plot the speed time graphs for the two cars as shown. Then the straight lines AB and CD describe the speed time graphs for first and the second car respectively. Distance traveled by a moving body is given by the area under its speed time graph. Distance traveled by first car, area of triangle AOB, that is half into OB into AO. Half OB is 14.4 into AO, that is time 5. It can be written as 1 upon 2, 144 upon 10 if we remove this decimal, and 5. It will become 72 upon 2 in turn, which is 36. We have calculated distance, that's why unit must be meters. Distance traveled by second car, area of triangle COD, that is half into OD into CO. Half into OD, that is 0.83 into time 10 seconds. It can be written as 1 upon 2 into 83 upon 100 into 10 in turn, which is 83 upon 20. 24 is 80, near about 4.1 meters. Thus, second car travels 4.1 meter and first car travels 36 meters before coming to rest. So, car A traveled more distance than car B after brakes were applied. Question 6. Figure 8.11 shows the distance time graph of three objects A, B and C. Study the graph and answer the following questions. Question A. Which of the three is traveling the fastest? As the slope of distance time graph represents speed of an object. B has maximum speed, that is, the object B moves the fastest. Second question. Are all three ever at the same point on the road? For meeting at any point on the road, the respective distance and the time values must be same for all the three objects at that point. As the three lines do not meet at a single point, the three objects never meet on the road. Third question, C part. How far has C traveled when B passes A? As it is clear from the graph, when B passes A at D, at this time C is at E, which corresponds to 7 km. Hence, when B crosses A, then C is at 7 km from the origin. Question D. How far has B travelled by the time it passes C? B crossed C at F at a distance of 4.5 kilometers from the origin. Question 7. A ball is gently dropped from a height of 20 meters. If its velocity increases uniformly at the rate of 10 meters per second square, with what velocity will it strike the ground? After what time will it strike the ground? According to question, given terms, height. Height is the distance, that's why denoted by S here, which is 20, denoted by A, which is 10 meter per second square. Initial velocity, as the ball is gently dropped, that's why initial velocity is 0. Final velocity, we have to calculate time taken t. We have to calculate. We will use third equation of motion. V square minus u square is equal to 2as. We have to calculate v. That's why we will move this u square to our second side, becoming positive. Now we will fill the values. 2 multiply acceleration multiply s, that is 20, plus u square in turn, which is 400. This is the value of v square. Now v is under root 400, which is 20. This is velocity, that's why meter per second. From formula of the acceleration, v minus u upon t, we can calculate t. T will be v minus u upon a. Now we will fill the value. V 20, initial velocity 0, acceleration 10. Hence it is 2 seconds.